Okay. Well, how's everybody doing today? Good. It's Friday. You got a 3-day weekend, so that's pretty good. A couple things. We are going to continue this lesson today. I'm not going to take up a whole lot of your time because I want to give you some time in class to work on your assignment, which is due Tuesday over sum and difference identities. So your test is on Thursday of next week, the 24th. Part of it will be the sum and difference identities. The other part will be coming from all the other identities we've talked about up to that point. But the double angle identities will not be on the test. Okay, and then very quickly after that, I'm hoping we should be able to get to equations. And then after that, we're going to move into a completely different topic, vectors. We're still going to be using the trig information, but now we'll actually start talking about some applications of those. So that'll be coming up hopefully in about 3 weeks or so. We'll kind of see how that plays out. All right, any questions about what's going to be happening? Okay, well, we started this yesterday. We have our 3 double angle identities for sine, cosine, and tangent. And we derived each of these by using the sum identities from our previous lesson. So sine of 2 theta was 2 sine theta cosine theta. What made cosine of 2 theta unique? It had 3 different versions. There were 3 possibilities. So when you're evaluating these expressions as the problems we're doing today, remember any of the 3 will give you the answer. When you're trying to verify a statement, like the proofs we've been working on, you want to think about which one is going to help you the best. Okay, but cosine of 2 theta equals cosine squared of theta minus sine squared of theta, which equals 1 minus 2 sine squared of theta, which also equals 2 cosine squared of theta minus 1. And our last one, tangent of 2 theta was 2 tangent theta divided by 1 minus tangent squared. Okay. And then I do not remember because every class kind of got to a different point yesterday. I know we started this, right?
Yeah.
Did we finish it? Okay, so we got A and B, but we did not get C. All right. So if we're going back, I'm wanting to say for this triangle, we saw that the hypotenuse was the square root of 17. So sine of 2 theta, we said that ultimately was 8 seventeenths. And then we said cosine of 2 theta was 15 seventeenths. Okay. So we have not done anything with C yet. Okay. Has anybody gone ahead and tried to solve it? Okay. Aiden, what'd you get? 8/15. That is absolutely right. Okay, so let's see how she got that. The formula we were just talking about, it was 2 tangent of theta over 1 minus tangent squared of theta. Start over here, give myself a little more room. So looking at the diagram, what is tangent of theta? Remember, what's tangent's ratio? It's what over what? Okay, y over r, so opposite over hypotenuse. Okay, what? Yeah, it's a Friday. I'm sorry, that's sine. Tangent is y over x. I'm sorry, yes. And I must have heard r. Went right with it. Okay, just saying if you aren't paying attention. There you go. So if you said that tangent is 1/4, you were correct. The opposite over the adjacent. Y over the x. Okay, so really, we've been talking about these identities as formulas. Once you know the correct formula you're going to use, then it's just a matter of finding these trig ratios and simplifying the algebra. So 2 tangent of theta would be 2 times 1/4 over 1 minus tangent squared, 1 minus, I'll plug in the 1/4, and then I'm going to go ahead and square that. All right, and then now we just run through the algebra. What do I get if I double a 1/4? Okay, that is going to be 1/16. What? Did I hear 1/16 or what happened? I must be hearing things today. Oh, the 1/16 are you talking about? I could have sworn I heard a 1/16. Okay, so I'm not completely off today. Okay, so if I double 1/4, I get 1/2. Now, if I square 1/4, okay, so I'm going to get the 1/16. So there we go. I'm back on track now. Maybe for a second. Now, I'm going to go ahead and combine these guys, so I, of course, need a common denominator. So I'm just going to replace the 1 with 16/16 because that's still 1, correct? But what does that give me in the denominator? There we go. So this is 1/2 divided by 15/16. And when we divide by a fraction, we multiply by the reciprocal. So we're going to have 1/2 times 16/15. All right. So you could go ahead and multiply straight across 16/30 and reduce that. I like to simplify on the diagonals if possible. So 2 will actually divide both 2 and 16. So we get the 8/15 that Aiden just told me a moment ago. Okay. Right. Did anybody else happen to work it and get that? Okay. Satish, good. Okay, Con, good. All right. Any questions? All right. Well, let's go ahead and work one more problem, and that's all we're going to have for today. So this one is slightly different. We are going to have to create the triangle ourselves, but as far as the identities and the simplifying, that remains the same. So we're given sine of theta is a -3/5, and we know that tangent of theta is greater than 0, so that tells me positive. So A, in which quadrant does theta terminate? Explain your reasoning. Okay, so let's think back a ways. What was the little phrase I taught you to remember where the trig functions were going to be positive? Yeah, so all students take calculus, right? So if I know where they're positive, I also know where they're negative. So where would sine be negative? What two quadrants? 3 and 4. Because think about it, remember sine represents the y value, and those two quadrants are where y would be negative. Okay. In order to get to those, we'd have to go down. What two quadrants will tangent be positive? Okay, 1 and 3. 1 and 3. There we go. Okay, so according to this, where should I be drawing my triangle? It's got to be in the third quadrant. Okay, good. So I'm just going to go ahead and say that the reference angle is theta. We don't know what theta is, and that's fine. But my terminal side rotated into the third quadrant. Okay, I'm going to connect it to the x-axis. And now I can use that ratio to figure out what the sides are going to be. Remember, sine is y over r. So this is the y over the r. The radius is never negative, so I'm going to go ahead and put that negative on the 3 right there. We could also use the Pythagorean theorem, but hopefully you'll recognize this as a 3, 4, 5. It is a triple, yes. 3 squared plus 4 squared will give me 5 squared, but there's something I'm missing. There you go. Again, we got to remember what quadrant we're in, so I'm going to go ahead and make that negative. Okay, so is anybody confused as to how I decided what quadrant or how I created the triangle once I did so? Okay. Now, using this triangle, very similar to what we did yesterday and actually a few moments ago, we just want to go ahead and evaluate all three of these: sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Well, if we're going to do so, we're going to need all three trig functions normally, so I'm just going to go ahead and list those. Sine of theta was already given to me. We know that's -3/5. Okay. Using my diagram, can anybody tell me what is cotangent of theta? Oh, good Lord, man. Yeah, I'm amazing today. Okay. Cosine of theta, I'm sorry. Okay, I'm going to make this pledge. Until the bell rings at 52, I will not make another mistake. I just set myself up to fail, but I'm going to do it. I'm going to do it. Make another mistake. Okay. So cosine of theta, what does that equal? That is a -4/5. Okay. I'll try to be real careful because I'm being recorded. And now what is tangent of theta? 3/4. Okay, that's the opposite over the adjacent, and the two negatives would give me a positive. And we know that tangent would definitely be positive in this quadrant. Okay, so now let's go ahead and start with sine of 2 theta. Let's get our identities, and let's plug in. So sine of 2 theta. Okay, let's see here. How about Skylar? What is the double angle identity for sine? Okay, So he says 2 sine theta cosine theta. Okay. Well, now that we know what the formula is, we just go ahead and plug in the values of the ratios that I need. So we have the 2 times, we were given sine of theta as -3/5, cosine of theta, -4/5. Okay, and we can put 2 over 1, multiplying 3 fractions. Okay, so can anybody tell me what would the product of those 3 ratios be? Should be 24 25ths. And it is going to be positive, the 2 negatives. So 2 times 3 times 4, and then 1 times 5 times 5. Okay, so just like that, we've got sine of 2 theta. Okay. All right. Now let's try cosine of 2 theta. Now, I'll go ahead and write out the identity in just a minute. Remember, there were 3 for cosine of 2 theta. What I want you to do, choose one of the 3 that you want to work with. Use that identity, simplify with the ratio or ratios that you need. Okay, so let me give you 1 minute. Okay, and then we'll see if we can all get the same response. Let's see how this one works. Okay, so I actually gave you a little more than a minute. Okay, so let's see. 33. Okay, so Jack. All right, what did you get, sir? Cosine 2 theta. 7/15? We're very close. Okay. 5. Ethan, what'd you get? Didn't have a chance to finish. Back to Jack. Okay. 22. Who's 22? Got 22 is not here today. 9. Didn't finish? Okay. Christian, do you have it?
Can I try?
You sure? 7/25. What do you guys think? That is correct. Yes. Let's see who would have come up next. 36. Nobody's there. Okay. All right. So it is 7/25. Okay. How many people had that right? Okay, good, good, good. So there are 3 to choose from. Okay, Shayna, which one would you like me to use? Okay, let's go with Alex. Which of the 3 identities for cosine 2 theta would you like? 1 minus 2 sine squared? Okay, so 1 minus 2 sine squared of theta. So 1 minus 2, we know sine is a -3/5. Okay, squared. And let's just start the process. -3/5 squared. Okay, so this is 1 minus 2 times 9/25. Okay. Now, if I double that, I'm going to get 1 minus what? 18/25. Okay. I need a common denominator, so I'm just going to replace this with 25/25. And 25 minus 18 will give me the 7/25. Okay. Now remember, a problem such as this, you have your choice of those 3 identities. Either of the other 2 will give you the same response. Okay, it's when you're verifying these equations, like those proofs, you want to think which of the three, if necessary, is going to be most useful to me. Okay, and there's only one left, tangent of 2 theta. Tangent of 2 theta. What was that identity again? 2 what? 2 tangent of theta over 1 minus tangent squared of theta. Okay. Would you like to try this one again on your own? Okay. So I'll give you a little more time this to go around. Let me give you 2 minutes. All right. So let's see. 18. Okay. Okay, 24/7. That's absolutely right. 24/7 what we're looking at. Good. Okay, so we said tangent of theta was it 3/4? So 2 times 3/4 over 1 minus tangent squared, 1 minus 3/4 squared. So if I double 3/4, I get, okay, 3/2, and 6/4 would reduce. So this is going to be 1 minus 9/16 equals. Now I'm going to go ahead and simplify. The 1 would be 16/16. Okay. So I'm going to have 3/2 over 7/16. Dividing by the fraction, multiply by the reciprocal, so 3/2 times 16/7. And you could go ahead, multiply straight across, but again, I like to simplify. And 3 times 8 is where I get that 24, 24/7. Okay. So how fun is this? Well, 24/7. That actually went over better in the other classes. So you'll laugh later. Tougher, tougher. Okay. Any questions? All right, then that's all I got for today. On Tuesday when we come in, we'll grade the homework. We'll talk about any questions, and then we'll start looking at verifying statements using the double angle identities. All right. Okay, so you can go ahead and listen to music while you work, as long as you're working. I encourage you to work together. If you have a question, let me know. Okay. And I'll see if I can't pass back your papers before you leave today. Okay.